Hey, what is up, brothers and sisters? Welcome to my channel. It is the Incredible Academic speaking. And guys, look, this is the questions that we're going to be tackling. Yes, these are the questions that we're going to be tackling. I don't know if we should start from number 7 up until number 9, but let's just start with number 7. Okay, given the arithmetic sequence, you can see that we've got negative numbers there. Let's get right into it. So number 7 is as follows. We need to be fast, eh? So number 7 is as follows. We've got what? Right, so we've got minus 5, we've got minus 4 and a quarter, we've got minus 3 and a half. All right, this is what we have. And obviously we don't want mixed numbers, okay? We don't want mixed numbers. So this is, when you're turning this into a mixed number, when you're dealing with negative numbers, guys, you need to be very careful. So minus 5 is to minus and then 4 and a half, right? Is to minus 3 and a half, right? You need to put the negative outside, right? So that you can be able to see clearly what number you're going to be turning into a mixed number. Without the negatives can be confusing. So basically our sequence is minus 5, right? And then minus into, so 4 times 4, that's 16 plus 1, that's 17 over 4. And then 3 times the 2, that's 6 plus the 1, that's 7. So we've got minus 7 over 2. I don't know why I put the bracket there, because it's no longer necessary. But anyway, this is what we have now. We've got minus 5, we've got minus 17 over 4, we've got minus 7 over 2. So, I mean, we've already been told, let's just check quickly, we've already been told that the sequence is arithmetic. So we don't even need to prove that. Do you understand? So meaning that we're immediately going to say, okay, we know for sure that the difference between the two consecutive terms, the consecutive terms is going to be constant. So we're going to say, okay, minus 17 over 4, right, minus 5, right, minus 5. This is minus 5, guys. The number is minus 5. So when you're subtracting it, make sure that it is still minus 5, because some people go ahead and say, okay, minus 17 over 4 minus 5, and then you'll be like, why are you subtracting 5? Because the number is minus 5, right? So minus 5. So the answer is what? 3 over 4. We do the same thing with the two numbers there. So minus 7 over 2, right? And then minus 17 divided by 4. Okay, so now what do we have? We still got 3 over 4. So we know for sure that the 3 over 4 is basically our D. Okay, that's our D. So now we need to check. Now we need to check. Just a second. We need to check what question are we being asked, right? What question are we being asked? So they're saying, which term in the sequence is equal to 13? All right, 13. One way of doing it is you could, just add the 3. You can just keep on adding the 3 over 4 to these terms here. Minus 7 over 2 plus 3 over 4. Whatever answer you get, add 3 over 4. Until you get to a point where when you count from the first term to that term, you've got 13. But hey, that's a very slow method, okay? So what we're going to do is, to make things a little bit faster, we're going to find the general term. So we know for sure that if we're dealing with a arithmetic sequence, Tn is going to be a plus n minus 1 times the d. All right, let's just avoid slow methods, because during the exam we won't have as much time. So A is the first term, and we know our first term here is -5. So -5 plus what? N minus 1, and then the D is what? The D is 3/4. The D is 3/4, so let's remove the brackets. So -5 plus 3/4 minus 3/4. So that becomes what? Minus, so we add the 5 and the 3/4, that becomes 23/4. So we've got an N there, plus 3/4. And I always, advise my learners to use calculators all the time, because well, I just calculated here using my head, simply because I'm not writing an exam right now. So even if I get this wrong, I don't have a problem with that, to understand. But in the exam, hey, use your calculator. Okay, so we've got the general term now. Okay, so meaning that we're ready to find what? We're ready to find T13. So T13 is simply going to be minus 23/4 plus 3/4, 13. Right. Now you see we don't have to do a lot of unnecessary work. So that's what? Minus 23/4 plus 0.75 times 13. And our answer is what? 4. Our answer is 4, meaning that term number 13 is equal to 4. Okay, so let's attempt answering another question. Let's see. So question B says, okay, we were asked which term in the sequence is equal to 13. So meaning that we're already given the term and we're supposed to find what? The position. So calculate the 30th term. So the 13th term is basically what we've just calculated here. So this answer here, it's for question B. So let's just write B. Right? Yes. That was just a minor mistake there. So let's go back to A. So to find the answer for A, which is the position of the term with a value of 13. So meaning that we're still going to use that Tn is equal to minus 23/4 plus 3/4 n. All right. So this time around we're given what? We're given the value and we need to find the position. So Tn is 13. It's very important to actually read, properly before you answer the question, because sometimes they're looking for the position, sometimes they're looking for the actual for the actual value. I hope you guys can see what I'm doing here. Alright, and then we divide throughout by 3/4. Divide throughout by 3/4. I simply took the minus 23/4 to the other side. So now we're ready to calculate. So our answer is going to be 13 plus 23 divided by 4 all over 3 divided by 4. Okay? And our answer is n is equal to 25. Okay? So meaning that term number 25, right, has got a value of 13. Do you understand? But this side, term number 13, right, term number 13 has got a value of what? Of 4, which makes sense. T13 has got 4, but T25 has got what? 13. Because I mean, term number 25 has to have the highest value, because this is increasing, remember. So that does make sense to me. All right, let's see if we can tackle another question. Okay, the 10th term of an arithmetic progression is 28. So we don't have the general term as yet. They're just saying T10 is equal to what? T10 is equal to 28. Very important. And we know it's arithmetic. Also, T7 is 19. So T7, right? The seventh term is 19. So T7 is 19. Let's see if there's any other information that is important. Calculate the first, second, and third terms of the progression. Okay, that's fine. So we need to use this information over there to find the term number. I mean the general term. Okay, so meaning that what we're going to do is we're going to say, okay, fine. If Tn is equal to a plus n minus 1d, therefore T10 must be equal to a into 10 minus 1d, which is what? So T10, but T10 is 28, right? So a plus 9d. T10 is 28, so 28 is equal to a plus 9d, right? And then this side as well. So this is our equation 1. This side as well, we know that the arithmetic sequence is given by that. So T7 must be equal to a plus 6d. Okay, right? And then we know T7 is 19. So 19 is equal to a plus 6d. Now this is going to be our equation what? 2, right? Let's use elimination because you can see that there's a, and like their coefficients are the same, so we don't even need to adjust anything. We just eliminate the 2. So let's put 28 is equal to a plus 9d.